In this video, we will talk about the fundamental theorem of algebra. So basically, what the fundamental theorem of algebra says is that if f of x is a polynomial of degree n that's greater than 0, and a is a non-zero real number, then f of x has exactly n linear factors such that you have this, this function, or this polynomial function, can be expressed as a times the linear factors x minus c1, x minus c2, all the way to x minus cn. So here, C1, C2, all the way to Cn are complex numbers. Okay, it doesn't necessarily have to be imaginary numbers. Remember that real numbers are also complex numbers. And therefore, f of x has n roots, and we will allow for multiplicity. So basically, what you kind of want to be able to get from here is that if you have a degree 3 polynomial, then you will have 3 roots. Okay, so if you have a polynomial of degree 3, then you're going to have 3 roots. And some of these may be complex. If you have a degree 10 polynomial, then that means you're going to have 10 roots. And some of them are going to just be complex as well. And some of them may have multiplicities as well. So just something to remember. So one more thing while we're in complex numbers. There's also another theorem that says, which is called the complex conjugate root theorem. Oops. Root theorem. And basically what that says is that if a plus bi is a complex or a root, then a minus bi is also a root. Okay, that's basically what that says. So when you're doing roots and you have a complex number, they always come in pairs. So the complex conjugate of this guy is going to be also a root for the other one. And that kind of makes sense because if you think about the quadratic formula, and if you're doing, like, I don't know, -3 plus or minus square root of whatever's in the inside divided by 2, if you end up getting a -4 in there, well, this is going to be 2i. Notice that you have this plus or minus thing in here. So it'll make sense for them to come in pairs. So if you know that one of them is complex, then the other one should also be complex as well. So let me give you an example. So we'll do a couple of them. So find the zeros of f of x equals 3x cubed plus 9x squared plus x plus 3 if x equals to -3 is a root. Okay, so here we want to find the zeros, and we know that x equals -3 is going to be a root. So, so when we know that something's going to be a root, we know that we can rewrite this root as this, x minus c1. Okay, so basically I can write x equals -3 as x plus 3 because I can add the 3 over. Okay, and you can see that if I have c1 as a root, I can write it as x minus c1. So if I have x equals -3, I can write it as x minus -3, which gives me a positive. Okay, so that's just a root. So now to find all the other roots, I can just use synthetic division. So I'm going to write down here, this is going to be a 3, a 9, a 1, and a 3. And then outside, you're going to have a -3. So I'm going to bring down the 3. You're going to get -9. It's going to give me 0. 0 times -3 gives me another 0. So you get a 1. And then -3. That's going to give me 0. Okay? So now what I have left is you can see that this f of x, this 3x cubed plus 9x squared plus x plus 3, can be written as this factor that I just had, x plus 3, and then times, well, since this was a cube, this is going to be a square, so it's going to be 3x squared plus 1. Okay? Now, in this case, since we want to find the roots, we already know what one root is x equals -3. So all we got to do is figure out what the other roots is. So let me set it equal to 0 because that's how we find the roots. We know x plus 3 equals 0, 3x plus squared plus 1 equals 0. Here x equals negative 3 is going to be a root, which we already knew. Here, this one, we can subtract by 1. You get 3x squared equals negative 1. I can divide by this 3. So I get x squared is equal to negative 1/3. And then when I do plus or minus, square root and plus or minus, you're going to see that x is equal to plus or minus I 1 over square root of 3. And then you can always just rationalize this if you want. So you get square root of 3 over 3. Okay, so basically see how this kind of came in pairs. So there's two of them. So here you have the first root, and here you have the other two roots. Okay, if you wanted to write the full factorization, then the way that we would write it, factorization, so the way that you would write it would be this x plus 3, and you'll have this x minus I square root of 3 over 3 times x plus I square root of 3 over 3. So this guy, if I were to FOIL all of this out, you would actually get this guy back. So if you want, so this is just basically using the fundamental theorem of algebra. Okay, so knowing that I can rewrite this as linear factors, I can easily figure out the full factorization. Okay, now let's do another example using still the fundamental theorem of algebra. So we want to find a fourth degree polynomial with real coefficients that has zeros, negative 3 to I, and f of negative 2 is equal to 100. Okay, so we want to find this fourth degree polynomial, and it has these coefficients and these as zeros. So if you remember from the fundamental theorem of algebra, a fourth degree polynomial is going to have 4 linear factors. So you can write this function as a, and then x minus c1, x minus c2, x minus c3, and x minus c4. That's basically what the fundamental theorem of algebra says. So here, c1, c2, c3, and c4 are all the zeros. Now notice that we only have 3 zeros. So we're missing one of them. Okay, so let's just write down the zeros for now. We have a, x minus negative 3, x minus 2, x minus I. So what would the other one be? Well, remember the complex conjugate root says that these guys come in pairs. So if I is a 0, then negative I is also a 0. So this guy's going to be x minus negative I. Okay. So let me clean this up. A, x plus 3, x minus 2. Then this guy's going to be x minus I, and then x plus I. All right. So now what we want to do, let's go ahead and FOIL all this out. Okay, so when I FOIL this guy out, you're just going to get x squared plus x minus 6. This guy, we know how to FOIL this out. So this guy is just going to give me x squared plus 1. Okay, and then finally what we're going to do is we're going to FOIL the last thing out. This is going to be crazy. So this is going to be just x to the 4th plus x cubed minus 5x squared plus x minus 6. Okay. So now what we want to do is, well, we need to figure out what this a value is. What is going to be this a? Well, that's where we're going to use this additional information. This f of negative 2 is equal to 100. So I'm going to plug in f of negative 2 into the function of a. So you're going to have negative 2 to the 4th power, negative 2 to the 3rd power, 5, negative 2 squared, plus negative 2 minus 6. Okay, So what we're going to do is we're going to put all of this into your calculator. Okay, so try to put it in your calculator. We know that f of negative 2 equals 100, so this guy's going to be 100. This thing is going to be an a, and this thing in purple, once you put it in the calculator, you get negative 20. Solving for a, divide by negative 20 over. You're going to get a is equal to negative 5. So now all we got to do is plug in this negative 5 back into the a. So we have that f of x is equal to negative 5 x to the 4th plus x cubed minus 5x squared plus x minus 6. And then all we're going to do is just FOIL it out. So it's going to be negative 5x to the 4th minus 5x cubed plus 25x squared minus 5x plus 30. So this is a 4th degree polynomial that has these roots, okay, all of these roots, and you have this function value in this function, okay. So nothing too crazy, okay. So be able to do the fundamental theorem of algebra very, very good. So these two problems, this one and this one as well, are really, really good problems to do, okay. So in the next video, we will do two problems where, because what we've been seeing is that we've been knowing a factor already, and we've been knowing the roots. But what can we do if in case we don't know anything about the function, we don't know anything about the roots? How can we do, how can we find all the zeros?